Daily arrivals of coal trucks dump their loads at this scale and stockpiling area. The 2-inch by 0 coal unloads through a grizzly and is conveyorized to stockpile as shown to the upper right, or continues on up the primary crusher house in the center building. Output from the primary continues up these conveyor galleries. There are dual conveyors that bring both coal and shredded bark and wood to the boiler. Bark is in the conveyors to the left and coal to the right. By removal of the hinged door on the Merrick feeder, we can see inside. Never do this when the pulverizer is operating.
There's a plug up, there's a rotary switch there, which will indicate that material is plugged this chute.
Now with the door replaced and bolted tight, the mill is brought up to 92% load, and we can now see the raw coal feed through the viewport. The coal contains 7% moisture and has 13,000 BTUs per pound. The raw coal drops down this stainless steel feed pipe into the pulverizer. Control of the coal feed rate is by the Williams microcomputer, which sets the feeder rate to exactly match the boiler demand signal.
Coming down into the mill. You cannot hear the mill in operation.
Each Williams DF mill is equipped with a tramp metal throwout. By opening this large gate, removal of tramp metal and hard-to-grind materials is accomplished. This is normally done periodically. Hard-to-grind particles such as iron pyrites, slate, and gravel will accumulate at the bottom of the fluid bed and can be dropped out of the system as needed. In addition, should it be necessary to empty the feed chute or mill for any reason, opening the gate and jogging the mill will do the job. The Williams patented DF pulverizer is manufactured in capacities ranging from 1 to 23 tons per hour of coal. The mill's drive skid assembly, shown here, is skid mounted for ease of removal.
200 horsepower motor. Rolling motor, motor. I mean for the clutch. It's rolling motor for the clutch. Rolling Alice clutch. Rain from the clutch. That's the gear ready to serve. All right. Give me the speed. Okay, 92 RPM. And you can hear this machine makes absolutely no noise.
The pulverizer cross-section, shown here, has a large access door through which journal assemblies are easily removed for yearly maintenance. So that we can better understand the overall mechanical function of the DF mill and their lubrication requirements, we show here a shop view of 6 mills under construction at our plant. The mill to the left has its cover and journals removed, while the mill to the right is complete with spinner separator. The journals are free to roll over uncrushables and pivot back out of the way. There are no springs or spring controls.
No, the journal itself.
Capacity adjustment is achieved from 100% to 0% output by varying the central rotational speed. Since centrifugal force varies as the square of the rotational speed, so production will increase or decrease accordingly. Air is used to dry and convey the pulverized coal. Shown to the left is the hot air damper. Central is the positive air shutoff damper used to isolate the system from the boiler. This is called the Paso valve. And to the right is the fresh air tempering damper used to control the mill outlet temperature to 150 degrees Fahrenheit. The hot gases are conveyed to circular bustles, which we call wind boxes. These wind boxes surround each pulverizer, and they introduce air equally around the periphery so as to fluidize the coal and dry it, and convey it up to the active classifier we call a spinner separator. Because of the active classifier design, sieve analysis for the pulverized coal remains constantly at 90-200 mesh. At high or low loads, there is 0-50 mesh oversize. Pulverized coal and air rise into the separator, where spinning blades force the heavier particles back down for regrinding at the mill zone.
Pulverized coal and classified it. The air stream with the coal comes up through this current, makes a turn, goes down through this line into the Chicago floor exhauster. And there it goes into the splitter valve, which splits the air stream and coal into 2 streams with 2 burners. Here we have the exhauster motor, 200 horsepower Westinghouse, 1180 RPM, connected. Exhauster turning in this direction, come out to the coal splitter, splits the air stream into 2 streams, 2 burners. Here we have the mill temperature thermocouple.
From the splitter valve, 2 pipe runs are used to transport the pulverized coal to each burner. Each pipe run has a coal flow cutoff valve, which is driven by an air cylinder. These valves are always closed when the pulverizer is shut down. This Foster Wheeler burner is equipped for coal, number 6 oil, and gas fuels, reducing the turbulence in the inner annular region nearest the fuel while directing the major portion of the air to the outer annulus lowers the flame temperature and NOx.